All right, integrated 3 students. So this video is definitely late upon arrival. I did want to give you all time to take ACT, which was yesterday, without having more content put in front of you and really focus on that. So hopefully everything went well with ACT yesterday. But we're going to be starting the new unit over equations of circles today. Let's get into it. Alrighty, so in your notes, it is time to start a new page. Last week, you would have taken your test over the beginning part of circles where we learned a lot of the basics about them. Now we're going to go into circles on a coordinate plane. So that's what we're going to be starting with. So unit 6.2 is equations of circles. There's going to be some other circle concepts that we get into here. But today we're really going to flesh out the core ideas of the equation of a circle. Okay. So here is the formula that you're going to need to write down for equation of a circle. It is x minus h squared plus y minus k squared equals r squared. Okay. And that is your equation. Any circle that you see on a coordinate plane, this is the format that it's going to follow. And I do hate that we're getting to this so late, especially the day after ACT, because it possibly could have helped you yesterday. But that's just sort of how the timeline lined up. But you'll get to take your ACT again in the fall, and hopefully, this information will be something that you keep with you. But this is our equation for the circle. Now, majority of questions are going to ask about the center of the circle. Of course, that's one of the most important aspects, center. Okay. The center will always be HK. Now, this may remind you a little bit about last year in iMath 2. You had what the vertex form of a parabola. It works very similar to this. But a lot of questions say, what is the center of the circle, or given the center, create the equation. It's going to give you a lot of things. And then the radius of the circle is r. Okay, so that gives you r squared always. That'll be important for some of the questions we're going to look at later. Let's go ahead and, of course, pull up Delta Math and look at some of the questions that you're going to have. So the very first section, and in my opinion, these are really quick problems. These are not too bad. Let me get there we go. We'll get this circle here. So really just wants you to create the equation of the circle, and you have to type it in exactly like what we have in our notes here in there to get those correct. Okay. So this is sort of the simplest form of questions that you're going to experience. So the first thing we have to do is we have to figure out what is the center. What is h? Okay, right? That's what we need. So how do we find the center? Well, it's the point where it's equally distanced from all the way around. So we go 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and we can go every direction. 1, 2, 3, 4, 5, 6. So this is our point here, HK, which is 0, 4, right? That's the center of our circle, and we determine that we can count every direction, and it should work out fine. Okay. Now, the next thing we want to know is, what is the radius? What is r? Well, r is equal to that distance from the center to the edge. So 1, 2, 3, 4, 5, 6. It's 6. All right, so then we need to create our equation. Well, it's x minus h, which is 0, right, squared, plus y minus k, which is 4, squared, equals r squared, so 6 squared. And then we're going to simplify that. Just anything that can be simplified, we're going to simplify. For instance, the 6, we got to raise it to the second power. X minus 0, that 0 is just going to go away, so we get x squared plus y minus 4 squared equals, this is going to be 36. So that's the equation that we actually want to type in for our answer. We're going to do that. X squared plus, we need parentheses, y minus 4 squared equals 36. Submit that, we have it. Okay, not too bad. Those questions should be pretty quick. Now, obviously, there's a lot of different types of questions that we could ask here with these problems, but this is sort of the basic information, the foundation that you guys are going to need to be successful with these equations of circles. You need to make sure you remember all these. Now, something else that I think is going to be very important is I want to know, how can we get a circle on our calculator for our graphing calculators? Okay, so if we look at this equation here, x squared plus y minus 4 squared equals 36. How can we type that into our calculator? If I pull up my Inspire, and I don't have the emulator, by the way, for the 80 series, unfortunately, so those using TI 80s, you're just going to have to listen along instead of see. But if I wanted to type this equation in, so I've got my Inspire up over here, there's a problem. And the problem is that this is not solved for y. Okay? So in your notes, let's actually add a section here, and I'll put a little star, graphing in a calculator. I think it's an important idea for us to think about. How would I go about getting this in my calculator? Well, we have to solve this equation for y. We need to get y equals, right? So how do we do that? Well, we just need to move the terms away from this left side. We need to get y by itself. And we've definitely done enough algebra in this class to be practiced at that. So the first thing that I would want to get rid of, remember, thinking of inverse operations, inverse order of operations. I can't square, by the way, a lot of students have said, hey, I need to square root this, that have done this in person. That can't happen because of this plus sign, okay? Inverse order of operations, I need to get rid of the plus sign first. How do I get rid of this x squared? Well, I'm going to subtract it, right? Minus x squared. Goes away, we get y minus 4 squared equals 36 minus x squared. Okay, cool. That works. Now, we can get rid of the square by square rooting. We do that to both sides. A little overzealous there with my square root. This becomes y minus 4 equals square root 36 minus x squared. Okay. And then we're going to add this 4 to both sides. That goes on the outside here. It goes away. We get y equals square root 36 minus x squared plus 4. All right, that's what we needed, and we are going to type that in. So I get square root 36 minus x squared. Those using the 80 series, I'd like you to try this as well. You're going to press your y equals button, and you clear everything, and then just type this in. All right, so I've got mine in. I'm going to hit enter. And if you can't see it, you can hit zoom standard on the 80 series. If you're using an Inspire, we just need to zoom, change our window to, we need our Y maximum to be 10. Go. Okay, and it's sort of, there's a big problem with it, but it's sort of starting to look like that. But what's the major issue? Well, it's only half a circle. Only half. And you should be seeing that on the 80 series as well. Why is this only going to be half a circle? Well, if you remember from your past classes about functions, a circle is not a function. Right? Go back to this. If we do the vertical line test on this, it fails, right? Going straight across here on the pencil. I don't know how your teacher would have taught it, middle school, I assume, or freshman year. I can't remember where it's actually taught, but the vertical line test fails. This is not a function. So how do we get this on our calculator, and where did we go wrong when we're trying to do this? Well, here is sort of an analogy, right? At this step here, we left off something crucial, right? And it sort of has the same idea as this. When I say x squared equals 9, right? We square root both sides. What is the answer to this? Well, a lot of students would say, oh, it's 3, but actually plus or minus 3. Plus or minus 3. Forgot that here. This is a plus or minus, and all the way through this is a plus or minus. And so we are going to have to copy the exact same function down. So you go back to your y equals. If you're in the Inspire, you're going to hit tab, which I don't know how many of you have Inspires at home. You're going to hit tab or y equals on the 80 series, and then you're going to retype this in, but now we want the negative version of it. Okay. And there we have a completed circle. Now I know that on the 80 series, like there's going to be some gaps. You can sort of see the gap here as well. There's definitely going to be some gaps in between these. It shows a little bit better, but it sort of looks like an oval on my screen. But this is by definition a circle, okay? Even though it's sort of skewed on our screen here, okay? So really, graphing calculators don't like graphing circles. However, Desmos doesn't really have many problems with it. If we go into Desmos, we can actually just type in exactly what we see. So x squared, or exactly what we had. So we don't even have to put it in the format. Just do that, and you can see there we have our circle. Okay, there is our circle for this. So Desmos, that's definitely one of the reasons it's a very powerful tool for graphing, is because it can graph things that are not usually functions, which is very handy, as you can see here. Okay, love Desmos for that. All right, okay. Next, in your notes, let's look at this next section of Delta Math and talk about what needs to happen with this. Let's just title this section in our notes what we see here. Circle equations with distance formula, okay? And I would like you to draw a sketch of this. You don't even have to have the grid. Just draw this right here, okay? Don't need the coordinate plane. Write this in your notes, circle equations with distance formula. Circle equations with distance formula. And that'll be good enough, okay? And here's the thing. We do already have our HK, right? We already have that, which is -3, -6. So we have that part. So if we're going to write up our equation, we have -3, oh, sorry, whoa. We have x minus -3, we'll fix that in a minute, squared, plus y minus -6 squared equals, and here's what our issue is. We don't know what r squared is, okay? Because here's the thing. We can't just look across and count because it's not exact. And if you do estimate, you are going to get the problem wrong. And we don't want to do that, okay? We definitely don't want to do that. So here's the strategy that you want to use on these problems. We are going to use the slope. Hold on, let me get rid of my dots here. I just want this. We're going to be using the rise and the run of this. Help us find this green line. What we're doing is we're trying to find, we're going to use Pythagorean theorem essentially. That's what they call it, distance formula, but really just we're going to understand it as Pythagorean theorem, because that's really all distance formula actually even is. And if you remember distance formula as Pythagorean theorem for the rest of your life, you're in good shape, okay? It's not that big of a deal to memorize things as the distance formula, okay? So what is our distance here? Well, we go over, wait, we don't know that one, do we? Oh, actually we do. We know the change to get to this point here. We want the change in x, right? So -3 to 0 is 3. And then -6, and I kind of drew my line a little too far over. -6 to -5 is 1, right? So we go over 3 and up 1. So really that's going to be 3 squared plus 1 squared equals, and this is r right here, right? So we're not even going to call that c squared. We're going to call it r squared. So really what I need to do is I got to square root both sides. So it's this, which is distance formula. So I'm going to put that as 9 plus 1, which equals square root 10. So what's going to happen? That's r. So when I plug this in down here, I'm going to get square root 10, and I'm squaring that. Okay, so now it's time to simplify all of this and we get our answer. So x minus negative 3, yeah, these are going to change to pluses. And this is going to become a 10. And that's how we're getting our answer for this. So that is our answer. The only step up that we see is that we're adding this idea that we can't calculate the radius by counting, which is going to be very important for several questions. It's important to use all these ideas that we've learned in coordinate geometry as we dive into this, okay? Oh, well, I wasn't able to check my answer, but I know that it was correct, okay? Okay, so I'm going to save this one here, the finding circle and center radius, for the next lesson. I'll start you guys off there, real soft, real easy. I do want to finish by saying that we have plenty of days here. Our test will be the 25th, 26th of this unit. We're sort of taking a slow approach here. Spring break is going to be this week, 29th through the 2nd. So we're not trying to speed run anything for these next week and a half. So I'll probably put up the next lesson tomorrow over finding center, circle center, and radius. That's going to involve a lot of algebra. Okay, and then of course we'll go over those as well. There probably is going to be more parts added to this. Okay. All right. If you have any questions, let me know.